So in today's lesson, we're going to continue to talk about transformations of quadratic relations. We've already talked about the effect of A on the graph in that it creates compressions, stretches, and or reflections. But today's inquiry assignment had you take a look at the effect of H and K on a quadratic relation. And so we're going to just try to kind of put it all together for you and discuss the effect of H and K. So hopefully if there was any points of confusion in what you learned about in that inquiry activity, this will sum it up for you and make it more clear. So if you took a look at that inquiry assignment and you changed the value of H, you probably saw that that caused the graph to move back and forth in a horizontal direction. And so that transformation is called a horizontal translation. We're just moving the graph left or right. And so we say, generally speaking, that the value of H moves the graph H units to the right. Okay, and so let me give you an example of that. So if, for example, I had the equation y equals x minus 2 all squared, then you may have noticed that what that does to the graph is it actually moves the graph 2 units to the right. And you may have initially thought, well, but it says minus. Shouldn't the minus be telling me that it's moving to the left? But you probably saw that it's the opposite. And so I want you to remember that this negative sign here really is part of that generalized formula and isn't a part of that H. So I would say that actually the H value for this question is not -2, but just +2, and that negative is built into the formula. Let me give you another example to help make this clear. So if I were to say to you y equals x plus 5 all squared, then I would say to you that the value of h in this question is actually -5, and that our graph would move 5 units to the left. And you might be like, but it says plus, so how can that be? I want you to think about it in this way. This is really what we're saying when we write plus 5. It's like I'm saying x minus, and this first minus right here is the minus that I have in the original formula. And I'm going to say minus 5, and the second minus is really just coming from the -5 that is my value of h. And so what happens when I subtract a negative? I end up with a positive. And so that's an explanation about why it is that when I write x plus 5, my h value is actually -5. Now, another way to think about it is you can just say, well, it's just the opposite sign to whatever is in the middle of my formula. So whatever strategy works for you to remember why it is that when we're talking about horizontal translations, we need to be careful about the sign of h. Okay, let's look at some practice questions. So I'm going to first start out by graphing our standard quadratic relation, which is y equals x squared. I'm going to do that one in black. And you'll remember we learned that, 1, 3, 5 method. So I'm going to plot my origin at 0, 0. I'm going to go over 1 and then up 1. And then I'm going to go over 1 and up 3 to plot at 2 and 4. And then over 1 and up 1, 2, 3, 4, 5. Plot another one at 3 and 9. And I'm going to use my axis of symmetry to help me get that mirrored on the other side. And now I'm going to try to do a nice smooth curve. I didn't do a fantastic job, but you get the gist of it. Let me give that another go. I'm not too happy with that, people. Let me try to draw that just a smidge better. There, I'm a little happier with that. I missed it down there, but that's okay. Boom, and I'm going to write my arrows down, and I'm also going to indicate what my equation is by writing the equation just next to the graph. So now what I'm going to do is I'm going to use my blue pen. And I'm going to say for the second equation here, y equals x minus 3 all squared, what is the value of h here? And so what I'm hoping you notice is that I need to remember that that negative that's right here is part of my formula. And so the value of h is actually 3. And so that's going to move my graph 3 units to the right. So I'm going to go ahead and move my vertex, move every single point in this graph 1, 2, 3 units over. And so my trick is to find that vertex at x equals 3, and then use my 1, 3, 5 method, but thinking about my axis of symmetry as being moved over 3 units as well. So it's like I have a new starting point. So I'm going to go 1 over 1 up, 1 over 1 up, 1 over 3 up, 1 over 1, 2, 3 up, and then 1 over and 5 up. Now, I could just have gone ahead and, used my previous points and moved them over, but I might not always have that y equals x squared plotted. So this just helps me to kind of, even if I hadn't had y equals x squared, I would be able to plot that. So I'm going to y equals x minus 3 all squared. Okay, so I would like for you to try out this last one to see how you do, to see if you would know what the graph of that function would look like. So pause the video, give that a try, and resume when you're ready. Okay, so I'm going to first identify that my value of h in this is -4, because remember, I need to think about the opposite sign to what's inside my brackets. And so that tells me that my graph is going to be 4 units to the left of my parent function y equals x squared. And so I'm going to move it over, and then I'm going to go from there and do my 1, 3, 5 method. And if I want, again, I can use that axis of symmetry to kind of keep me centered and oriented. 1, 2, 3, and then, except I'm supposed to be doing this at 4. So let me just start that over. And so 1 over, 1 up, 1 over 3 up, 1 over 5 up. And then I'm going to mirror that on my other side, again with my axis of symmetry being right down through the center of my vertex. There we go. So that's done. And again, I'm going to try to do that nice smooth curve, which is tricky to do on this piece of technology and also my shaky hand. And I'm going to label it y equals x plus 4 all squared. So there I go. I've graphed these transformations. Okay, so next we're going to take a closer look at what the value of k does to the graph of y equals x squared. And so we've done actually the harder part of this. We're ready to move on to the easier part. You probably noticed that the value of k moves the graph up and down, okay? So what might we call a transformation where the graph moves up and down? This is called a vertical translation. And we don't need to worry about any of the negative positive business, because in this case, the formula has a positive k, so plus k. So we know that if k is if we have plus a value, then our graph is going to move up by that amount. Let me just clarify that to make sure everybody's on the same page. So if, for example, I had y equals, let's say, x squared plus 7, then that plus 7 that's there tells me my k value. My k value in this case is 7, and that means my graph moves 7 units up. However, if I have a value of k that is negative, I would see that as a subtraction. So x squared, let's say minus 5, for instance. Then that would mean that my k value is -5, and my graph moves 5 units down instead. Okay, so let's do a little bit of practice with that. So just a couple of things I want to point out about the difference between whether we're looking at something that's an H or a K. The H, or the horizontal translations, are inside the bracket with our x variable, and the whole thing is squared. So that's how I'm going to tell that that's the side-to-side or horizontal translation. The K is outside the brackets, far away from my x, and isn't squared. Okay, and we'll do some practice identifying what the heck's going on near the end of this video. Let's practice some graphing. So in this case, in this example, I'm looking at you graphing a few translations, and but it's always good to start by graphing that parent function y equals x squared. So I'm gonna go ahead and do that in black, just like we did in the last question. So I've got my 1 up, 1 over, 1 over, 1 up, 1 over 3 up, not 2, 4, and then 1 over 5 up. So at 3 and 9, mirroring that on the other side. And then trying to draw a nice smooth graph. And of course, adding my proper label. I'm going to do the next graph in blue. So notice here that the x squared is kind of like, I can think of this as y equals x plus 0 all squared plus 1. So I can tell here that my h value is 0, which means I'm not moving this graph side to side. But my k value is positive 1, which means that my graph is simply moving up 1 unit. So I'm going to move up 1 unit and then do the same pattern of 1 over 1 up, 1 over 3 up, 1 over and 5 up. Right, and I have my original parent function, so that's actually easier here because I can just sort of take the coordinates that are there and just move them up 1, right? Up 1 and then up 1. So that's kind of handy. Now I'm going to mirror this on the other side and then try to create that smooth graph. And it's a little tricky because these are overlapping. X squared plus 1. Okay, so I would like for you to try this next graph, which is y equals x squared minus 3. And then pause the video, graph it out, and then we'll check it. Okay, so in this case, I can see that my k value is actually negative 3, which means that my graph should be moving down 3 units. So I'm going to take my existing vertex and move it down 3 units, and then continue with my 1, 3, 5 pattern. And I could even actually add another point. No, I can't. 1, 2, 3. Mirroring that on the other side, and so on and so forth. And then creating that smooth graph, 1 over and 5 up. And so I've just taken the existing graph and moved it down 3 units. I hope you did okay with that. We're going to look at how, if we know the values of h and k, we can actually just identify where the vertex is of our transformation. So the vertex we can know if we look at the equation of our function, because the vertex is located at h and k. Whatever the values of h and k are, tell us our vertex. Because remember that h tells us how far our graph is moved side to side, and k tells us how much our graph is moved up and down. So let's kind of practice that. Let me show you what I mean. Let's say I had an equation like x minus 3 all squared plus 4. Now when I look at this, I'm going to first identify what my h value is and what my k value is. So I can tell that my h value in this is 3, right? Because it's in the position that h would normally be. And then I'm going to look and see, well, what's in the position, my k position? Well, that's a 4. And so my k value is at 4. So I can therefore say that my vertex is at 3 and 4. And so that's a great way to know to graph a function really easily, because if I have a Cartesian plane and I happen to know that this function isn't stretched at all, I can see here that there's nothing where a should be, which implies that a is 1. There's no stretch, no compression. Then I can go ahead and I can locate that vertex on the graph. It would be at 3 over, so imagine that this is 3, and and 4 up, so imagine here we have 4, right? And then I would simply have my graph, right? If that's my vertex, then I could use my 1 over 1 up trick, my 1-3-5 method to plot my graph. Okay, so super helpful to know that h and k is my vertex. Let's do some practice. So what I want you to do for each of the following is to take a minute to try and locate the coordinate of the vertex for each of these problems, and when you're ready, we will take them up. So pause the video and give that a try. So I always find it helpful to identify what my h and my k are. So I would kind of set myself up saying what is h and what is k in each question. And so in the first question, my h value is 4 and my k value is 5. So I put that in, and then it's really just easy peasy to get my vertex. My vertex would therefore be at 4, 5. Now, it gets a little bit trickier when we take a look at when we look at there being a plus value inside our brackets, remembering that, we need to look at the opposite sign for our actual h value compared to what's inside that bracket. So the value of h here is actually -7, and the k value is 1. So my vertex is therefore at -7 and 1. Hopefully you did okay with that. Now let's look at the next equation. So all I'm asking you for for this function is to identify the coordinates of the vertex. Now you'll notice that this 3 right here is in the position of A, and it has nothing to do with identifying the position of the vertex. So for the purposes of this exercise, we're going to kind of just ignore it. We don't really need to pay attention to it. It does tell us that our graph is stretched, but we're not really concerned about that for this question. We really only care about identifying h and k so that we have our vertex. So the h value here is 1, and our k value is -6. And so that tells us that our vertex is at 1 and -6. Hopefully you did okay with that. Moving on to the next question. My h value in this case happens to be -2. But what the heck is my k value, right? How am I going to get my k value? It looks like there's actually nothing there. Well, I want you to think about the lack of k values being almost like we're saying +0. And we wouldn't have to put in +0. We would just kind of just not include it at all. So I would say that my k value here is just 0. We just didn't write it in. And so that allows me to say that my vertex is at -2 and 0. So I haven't seen any kind of vertical translation for this, right? I haven't moved my graph up or down. It's just kind of stayed and moved 2 units to the left on my x-axis. So maybe that will help you with the last 2 questions if you didn't quite get them when you were pausing. Let's take a look. So again, when I look at this equation, I'm seeing this 0.6 in front in the position of A. That tells me my stretch, compression, or reflection, so I don't really care about it. Now, the next part, I'm going to just, for a minute here so you can see it, I'm going to rewrite this. I'm going to rewrite it like 0.6 x minus 0 all squared minus 8, because that might help you to see what our h value is. Now, I know that if I had an h value of 0, I wouldn't actually write in x minus 0. That would just sum up to be just x squared, right? And then my brackets would be gone. So that's actually what's happened here. So my h value in this question was a little bit hidden, not very obvious, but it is 0. My k value, on the other hand, is this -8. That's kind of a little bit distanced from my x squared. So that tells me that my graph has been moved down by 8 units. So what is the vertex in this case? It is 0 and -8. Okay, now I'm a little crowded, so I'm going to move the answers to this last question over here. Now, y equals 9x squared is sort of like saying 9 bracket x minus 0 all squared plus 0. So I just haven't written them because, well, the value is 0, so I can kind of simplify that. So when I do that, my x minus 0 is just really x squared. And of course, without any value inside the bracket, I can just kind of drop those brackets altogether. And then plus 0 means I'm not adding anything to the end of that. So my h value in this question is 0. And my k value is also 0, which means that my vertex is at 0, 0. My graph has not been translated horizontally or vertically. So that's it, folks. That is it for our lesson on translations. Do the best that you can with this, and if you struggle, not a problem. We will be doing a worksheet tomorrow to solidify this and doing a warm-up before we start. So just do the very best that you can to make sense of this, and we'll pull it all together on our next lesson.